Okay, so we talked about functions, and in order to be a function, it has to pass the horizontal line test. We'll get into more detail about that later, but that's something to keep in mind when we start looking at a piecewise function. It's called a piecewise function because when everything is said and done, it still has to be a function. There are a couple different ways to handle this depending on what makes you happiest and or what you've already learned. Some people like to draw the entire graph and then erase the parts that you don't need. Other people can get by just doing the parts that we need. I happen to be fairly good at this, so I would do just the parts that we need, but if you were an eraser type person, by all means, knock yourself out. So let's graph this bad boy. What can you tell me about 2x plus 3, Armin?
Linear.
Keep going.
Linear's up to 3.
Yeah.
Slope's 2.
Do we need anything else?
No.
No, life is good. Is the, because this is a x less than 0, is it an open circle or a solid dot at 0?
Open circle.
Open circle. 1, 2, 3, open circle. Slope of 2 over 2, down 1, and something like that. Takes care of this. Check. X squared. Again, if you feel the need to draw the entire parabola, by all means, knock yourself out. However, I know that I'm going to start at 0. It's going to be a solid dot. Does everybody understand why it's a solid dot?
Yes.
Does everybody not? Beautiful. Then over at 2, 2 goes up to 4. That one's an open circle. Goes through 1, 1. There's my parabola. And last but not least, what's this look like? Keep going. What about that?
Y equals 1.
Good. Solid dot or open circle?
Solid.
Solid dot. Okay. There's my piecewise function. I know it's a function because no matter where I put a vertical line, I'm going to still only hit the graph in one point. In particular, when you finish your piecewise function, you probably want to look at the end of one part and the start of another to make sure that they're not both solid dots. They can both be open, they just can't both be solid dots. Just for giggles, what's the domain of that completed function? All reals. Beautiful. Any problem with that? How about the range? Domain is equal to negative infinity to infinity, or as many said, all reals, a capital R with an extra line on it. What's the range? Negative infinity to 4 to 0?
4.
Just 4?
Oh, whoa.
Whoa,
Zero. I don't know. Actually.
3?
No, it's to 4.
Oh, yeah, it's
4. 4. Parenthesis or bracket?
Parentheses.
Good. So like I talked about yesterday, if you struggle with domain and range, and you're like me, pictures will help you solve those domain and range problems. So anytime I can draw an accurate picture of the graph, I find that a lot easier than having to play with numbers. Sometimes, however, you're just going to have to grind them out, but in a case like this, looking at the picture is a lot easier. Okay? Problems with piecewise. They don't get that nasty. The individual functions are usually pretty simple. It's putting them all together that makes it sometimes challenging. Transforming functions, starting with a mother function, and moving it around and flipping it over. So here are some examples of what I can do with a basic parabola graph. Slide it up, move it left, flip it over, and do both. When you have, let me get to this. If you look at something like the last statement here, what order do you go in? It follows Aunt Sally's rules. Please excuse my dear Aunt Sally. So would I do the negative sign first, the +3, or the +1 first? Plus 3, because it's inside the parentheses. Do I do the negative sign or the plus 1 next? Negative sign, because that's multiplication. Okay, so I'd slide it to the left 3 units, I would flip it over, and then I would add 1 by shifting it up. Okay. All of that is summarized there, but you knew this already. You start with the basic function of f of x, the next 4 are all the translational up, down, left, and right. Then we've got to reflect over the y-axis, or x-axis, y-axis in origin. You'll recall that when we did symmetry, we don't like to reflect something over the y-axis, but that's only for symmetry. For transformations, we're fine. If, for instance, you start with the square root function, there's no reason why you can't flip the square root function over the x-axis. That's okay. It just turns it into the bottom half of that sideways parabola. You did all this last year, yes? Yes. Beautiful. We're done. Easy peasy. Now, the reason I broke it here is because I want to give us a lot of time to finish up that trig packet and answer questions about that, and also to take a look at some of the problems from last night.